Okay, so we're gonna get started. Hi everyone, welcome to the last Tropilunch of the semester. So before we go into our speaker, just a reminder that this weekend is the bingo. So we'll be sending a reminder in the list server. So pay attention to that, and don't forget to participate. So for the last Tropilunch, we have Oscar. Oscar Godinez is a biologist with a master's degree in integrative ecology from Michoacán University, Mexico. He's a PhD student in interdisciplinary ecology from the School of Natural Resources and Environment, supervised by Dr. Robert Fletcher and Robert McCleary. His PhD is a collaborative work developed in partnership with the National Commission for Knowledge and Use of Biodiversity. Oscar explores how human-induced changes influence biodiversity, combining ecological research, conservation biology, spatial analysis, and community-based monitoring to support inclusive and effective conservation. So with that, thank you, Oscar, and the floor is yours. Thank you.
Well, it's really strange to be here on this side because normally I'm on the other side. So it's a different experience, I guess. So I will talk about forest and forest ecosystems in Mexico, particularly. I will talk about a project that we have implemented in Mexico that it is led by the CONABI, or the National Commission for Knowledge and Use of Biodiversity, with a long name. So,
No. Yes. Okay. Yeah, you can use this.
well, so I will start just showing a collage of a forest because forest is synonymous of life. You can find different species, very emblematic species, such as the tapir, that is my favorite species in the world. And also in these areas, human populations are strongly linked to this forest. We have a lot of cultural diversity thanks to the forest. And also we have different deep benefits from forest. Even we can classify these benefits in some using a concept that we call ecosystem services. And we have different services such as biodiversity support, carbon storage, climate regulation, and other ecosystem services. So the message here is really clear. The forests are important for us and also for biodiversity. Unfortunately, well, we have transformed the forest a lot. I just take this information from the Global Forest Watch. They mentioned that they reported from 2001 to 2024, we lost more than 500 million hectares of forest. It represents more than 12% of the forest cover. It's a lot. So to have an idea, for example, a football stadium, the size, the average size is of 1 hectare or 1.5 hectares. So we are talking about more than 500 million of football stadiums. That's really a lot. So that's why monitoring forests is really important. And we already know that. It's really important because we can understand more about the dynamics of human populations and interaction with the environment, and also for informing policies, enforcing regulations, adapting management practices to effectively conserve biodiversity, maintain ecosystem services, and of course, human well-being. So we have done a really good progress, I guess, doing this. For example, we have more information and understanding of what about the area that we are losing. And that's why I was able to give you this example from the Global Forest Watch. But something different is that we have limited information about the quality of the remaining forests. And this is really simple to explain because it is really difficult. As we can see here, we have a satellite image, and we can say certainly, well, this is forest. We can classify this as forest. But we don't have a lot of information about the structure, for example, of the forest. We don't have a lot of information about the function of the forest and the composition. So we could have different mixture of mature forest, for example, or an ecological degraded forest. And well, as I mentioned, why it's so difficult to get information about the quality of the forest? Well, it's because it's really difficult to quantify this quality. We have different approaches that they are using different elements of the forest, such as the structure, the composition, only the function, only the structure. So we don't have a standardized method for quantifying the forest quality. But we have a lot of approaches, certainly. But we decided to use a common approach that it appears in a lot of global targets, and it is the integrity work. So it appears in different international and national instruments. We can see, for example, one of the most popular, for example, the Montreal Global Biodiversity Framework, where we have some of the most important targets that they are using the ecological integrity work. And also we have some national targets like the National Biodiversity Strategy of Mexico, where we are also considering the ecological integrity. So it looks like the ecological integrity is a good approach. But the problem is that it's difficult to explain what's ecological integrity. It's a concept that it has been used, or the free register of the ecological integrity concept, or idea at least, is from Leopold in 1949. And since that moment, it has been changed a lot. Some people have added a lot of terminology, but I think now we have a general idea about what's ecological integrity, or at least a consensus between researchers. So I'm using this concept of ecological integrity. It is the extent to which the composition, the structure, and function of an ecosystem fall within their natural range of variation or the historical range of variation. What I mean for composition, for example, is the diversity of species, species diversity. The structure is, for example, the structure of the vegetation, or the different abiotic elements in the forest. The function, I'm referring to ecological processes, for example, the ecological connectivity. Okay? So it looks like if we characterize these different components of the ecological integrity, we will have a good approach or a good indicator. And the idea is really simple, and I guess we use this all the time. The idea is to compare a reference state with their structure composition with a recent state. Depending on how different they are, we can say, well, this has high integrity or low integrity. So that's the idea behind the ecological integrity, and we use this all the time. So we have different gaps. We don't have an standardized methodology, and that's logical. But particularly, we don't have a standardized methodology to analyze spatial and temporal trends. And also, we don't have a characterization of these spatial and temporal trends across biomes. And also, we don't have a lot of information on how well or how effective are protected areas conserving ecological integrity. So in this talk and in this project, we are trying to fill some of these gaps. We are trying to contribute to fill these gaps. And I will focus on country that is my country, that is Mexico. And that is because, well, Mexico is beautiful, negative country. But also because we are really lucky. We have two regional areas. We have a transition area between the Nearctic and the tropical region. And we can find here different forest ecosystems that I can characterize using biomes. So in general, we can find temperate forests, dry forests, and rainforests. And that's why Mexico is highly biodiverse. But the sad story is that we have also a lot of transformation of these forest ecosystems. An indicator is the deforestation, that is probably the worst of these indicators or transformations. These are some of the official data or information about deforestation of Mexico. And we can see that we are losing thousands and thousands of hectares each year. So, for example, the rainforest, we are losing more than 80,000 hectares per year since 2001. That's a lot. And they are the official data. What's the main reason? Well, the conversion to agriculture, pastures for livestock grazing. That's the main reason. So the objective in this talk and this study is to assess the ecological integrity of forest ecosystems or forest biomes, and to analyze their spatial and temporal trends, including those within protected areas. So what to expect? I will try to explain this 4 different parts. The first is the ecological integrity trends between 2001 and 2024. The second is how effective are protected areas preserving this ecological integrity. The third is how deforestation affects surrounding forest integrity. And the fourth is just really fast to show you a participatory monitoring system at local scale. We are monitoring different levels of ecological integrity. So first, this is probably the most difficult part because it's the method, but I will just talk about this very superficially. But if you have some doubt or some comment, you can talk in person. But as I mentioned, it's very difficult to quantify ecological integrity. And there are different approaches. So we decided to use a concept that we call hemerody, or some people call it naturalness. And what's hemerody? It's really simple. It's a proxy of ecological integrity that captures human influence on vegetation. And so the idea is to compare the potential natural state versus the current state. At the end, we can find, like, we could get this range of values with low hemerody in areas where we have forest potentially, and currently we have forest too, for example. Or a high hemerody and low integrity in areas where we have potential of forest, and now we have a city, for example. So this is very difficult because we have to take different decisions. You know? And the first is the transitions and the hemerody values. But fortunately, I'm using a framework that the CONAVIO, that is a federal institution in Mexico, they organized. Also collaborating with the National Institution of Mexico, the UNAM, and also the Institution of Ecology Institution of Mexico, INECOL. So participated a lot of experts to select these different hemerody values. So we have different transitions and different hemerody status. At the end, the idea was to get a map of hemerody. In this example, what we are using is a map of hemerody for 2017. And that is because this is the year with the high resolution, high climatic resolution classification map from Mexico that we have available. So we have this map of 2017, that's it. Then we are trying to predict the hemerody using different control variables, ecosystem structure variables, and also function variables. We are using some machine learning approach that it is called XGBoost. It's very interesting. And the idea is to try to predict the hemerody for 2017. And once we got a really good model, predictor predictory model, we can now predict for other years. So it was a really successful exercise. We got like an 80% of accuracy in the predictive model. And we were able to predict the hemorrhage for the other years. And also to construct ecological integrity index that is normalizing these values between 0 and 18. And it transformed these values between 0 and 1. Value of 1 means that we have a high integrity. A value 0 means that we have a low integrity. So yeah, we have these ecological integrity maps. Now we can answer some questions. And the first is the ecological integrity trends. So we use these maps to apply a pixel-wise trend analysis. That is probably the simplest test of trend analysis. So what we got? We got this map, this kind of map that I simplified in these three different categories with significant values. So we have in green values of where the ecological integrity is increasing. And also we have in brown areas where the ecological integrity is decreasing. And also we can see in gray some areas where the ecological integrity is stable or it doesn't show a pattern or a trend. So the main data I can say you is that we have more than 20% of the forest that is showing an increase in ecological integrity, and that's a good news, I guess. But also we are observing a decrease in integrity in more than 30% of the forest, remaining forest in Mexico. And also we have different responses between biomes. We are here observing a bar plot with the different biomes and also the decreasing in trend in terms of area. So we can observe that the rainforests have experienced the greatest integrity loss during this period, more than 80%. That it's reasonable. But the problem is that we are observing that also some protected areas are not exempt from degradation. And this is really interesting. This is one of my study areas. This is the highlands of Chiapas. And here we have some of the most beautiful protected areas with close forests, for example. And we can observe that we have some decrease in integrity even inside protected areas. So also we can see that these protected areas, some protected areas are doing better than others. For example, here we can observe that in the south part of this region, the protected areas are showing a lot of decrease in integrity. And in the north part, they are not where they are showing a decrease, but not a lot. So we have an heterogeneity in the response. But also we can use this information to do a really fast exercise of prioritization. And we can combine this trend analysis with, for example, a recent ecological integrity, that is the 2023. And we can get different categories comparing these two maps, but I will focus just on these three categories. The first is high ecological integrity in a recent period versus that is showing a decline in integrity. So what it means? Well, it means that we need urgent, or it means that urgent treat. We need to focalize here conservation and restoration activities. Also, we have this other combination of medium integrity, but it is showing a decline in integrity. So we can understand this as an early warning. And also we can have high integrity areas that they are stable, or they don't show like a trend. So this could be a conservation strongholds. So the map for result maps looks like this. And what I can rescue from this, well, about 1/3 of Mexico's remaining forests show warning signs of declining integrity, while only 15% persist as stable strongholds. So this is really interesting because we can play with this data and to have some prioritization exercises. And we can observe more if we zoom in this area, and we explore what's going on inside protected areas. If we explore this, it looks like there are both success stories and warning signs too. And for example, we have that 12% of the forest that is inside protected areas are showing these urgent threats, and also early warning, 14%. So that's why we decided to answer, or to try to answer this question, like, how effective are protected areas in preserving ecological integrity? We already have some data, but we decided to use another more statistical approach to have a fair comparison. The idea is to use we were using the propensity score matching, that is a matching statistic. And it's really simple. The idea is to select some areas of pixels that are inside protected areas and to compare with unprotected pixels that they are similar in elevation and line to line color. So in that way, we can have a fair comparison. And then we estimate the effect size, summarizing the points as the indicator. That it means that if we have positive values in this effect size, the protected areas are in some way more effective than unprotected land. If we have negative values, it means that protected areas are not much more effective than unprotected. So of course, we consider that protected areas are not established at the same time. So some protected areas were established before 2001, and others are established just recently. So what we can see here are different years of cohort and years of different periods of where the protected areas were established in Mexico. So the main message is that they are improving over time. They are doing a good job, the recent protected areas. But the older protected areas, they are not really performing poorly, conserving ecological integrity. And they represent 28% of the protected areas in Mexico. And it looks like a value, really small value, for example. But if we explore this 28% of the protected areas, we can see that more of them are federal protected areas and stattal protected areas. And this is really concerning because these protected areas are they have the highest budget, for example. They have more resources for conservation. They are the biggest one in Mexico too. But they are showing like a poor performing. And also we have the ADVCs that they are showing a different pattern. This is a pretty interesting result because the ADVCs are community protected areas or HIDAL protected areas. So they are doing apparently a good job conserving this ecological integrity. So now we have an idea of the protected areas, how effective they are. Now we were trying to explain more about what's behind this ecological integrity decline. So we decided to focus on deforestation because we have different anthropogenic disturbances, but the deforestation probably is the worst of all of them, I guess, at least since a landscape ecology perspective, because we are losing totally the forest. And also because when we have deforestation, we could have other effects on the surrounding forest. So, of course, it occurs a deforestation event, and we are losing a lot of integrity or the total integrity. But also, we are affecting the surrounding forest, or that's the idea or the hypothesis we have. So we were using generalized additive models. I will not enter in detail, but I want to mention that we were using some predictable variables. And these are the proportion of forest loss. That is, well, probably if we have an event of deforestation, really nearby forests, probably we will increase the probability that the integrity around decrease. And also we have the distance to nearest forest laws. So the idea is that we are close to these areas of deforestation. The integrity probably will also decline. And also we are exploring these other variables, the baseline ecological integrity. So how important is the baseline? If we have a high integrity, these areas of high integrity will continue like high integrity, or they will decline. Or and also the forest proportion in the neighborhood. This is the forest amount. How important is the forest amount to predict this decline in integrity or change in integrity? So I will summarize these results in 4 different results. The first is local deforestation drives integrity loss. That is logical. More nearby forest loss means stronger declines in ecological integrity. Also, proximity amplifies degradation. That means pixels closer to deforestation will show also a decline in integrity. The third is, well, initial integrity strongly shapes how much change occurs. And that is, well, if we have a high integrity forest in 2001, is more vulnerable to decline. And also, if we have in 2001 a low integrity forest, it shows normally and a small recovery. The fourth is and this is really interesting, I guess, forest amount does not influence integrity change for now in our analysis. So it doesn't matter the forest amount. It looks like it is more important the disturbance. So, well, some takeaways from this part is that loss of ecological integrity extends beyond deforestation. So we have to consider that we have to analyze more than the quantity of forest we are losing, also the quality, using different indicators. In this case, I'm using ecological integrity, but we can use other indicators. So the remaining forests continue to degrade in structure, composition, and function. So we have a lot of uncertainty about the resilience of these forests. Also, the rainforests have experienced greater integrity loss compared to dry and temperate forests in Mexico. And while protected areas are essential for forest conservation, they are not immune to degradation. So we have to look at this and probably to focalize more conservation, restoration, and management activities in these areas. Also, ecological systems are complex. We have not forget that. We normally generalize a lot, but anthropogenic disturbances are likely to generate much more damage than we have estimated. So, and also for Mexico is very interesting and very important in this project, I guess. Because recently we have, well, the federal government presented the Mexico's National Environmental Restoration Plan. So the idea is to restore more than 100,000 hectares of forest. So it looks like we could use this kind of tools and products to also focalize some of the efforts to restore the forest. And well, now we'll talk really fast about the participatory monitoring system we have in Mexico. And the idea behind is to compare biodiversity using different levels of ecological integrity. Well, this has been a really interesting experience. It's more talk about the experience behind this. The name is the Permanent Sites for Biodiversity Calibration and Monitoring. In the federal government, we don't use a lot of nice names, but we can call it CPCAM. So the idea is behind is that we are working with a lot of collaborators. They are researchers from universities, NGOs, and government agencies. So we are working together to implement a monitoring system. Second, well, once we have these groups of colleagues, we go to the communities. We try to implement this monitoring system, having some meetings with ejidos and communities, and also having some agreements. For example, we are paying for working hours. So this is a really important part, to have an agreement with local communities and ejidos, because they normally in Mexico, this is very characteristic in Mexico, the people is the owner of the land. So they take decision as a collective in the rural areas normally. And they decide who will participate in each activity, if they will participate all or not. So they are avoiding all the time conflicts inside the community. So that's why it's really important to talk first with the community. Then we implement some local capacities building. That is, we have some training workshops in the use of camera traps, audio device, Sherman traps, and data sharing tools. That is to share the information with us. What's the best way? So they are manipulating the SD targets, no, SG cards, sorry. So they manipulate information and they share that information with us. So we are capacitating these people to do that. And well, they are doing a really good job. Sometimes they are really, and this is a really important part because we designed this monitoring system using the previous maps, the ecological integrity maps. So of course, in the map, it looks like a high integrity area, but when we go to the field, it looks like it's not a really high integrity area. It's for sometimes a low integrity area, or we don't have forest. So that's why it's really important the knowledge of the territory of these people, because they can say, well, we should allocate these camera traps in other area where I consider that there is a high integrity. So we are using that knowledge of the territory. We are monitoring the 3 different biomes. Well, I'm participating in these 3. They are monitoring all the biomes using camera traps and also using the participation of people. So we are getting a lot of different information from camera traps, a lot of reports of different species. Some of them are vulnerable species. And also we are getting information about some illegal activities. So what's in progress? Well, we are using this information to refine the integrity models, the maps that I showed earlier. Also, we are assessing the biodiversity response. This is part of my second and third chapter, like of the thesis dissertation, like to analyze how have changed the biodiversity in low, medium integrity areas versus high integrity areas. And also, we are strengthening community monitoring. We have some, for example, in Michoacan state, that is my state in Mexico. After we conclude the monitoring system, some women, they have now a group of monitoring, and they request us like some workshops to continue, like knowing more about how the camera traps works and also the audio devices. And also, finally, to share results locally to support decision makings in the community and also in the federal government. So I'm participating on this, but I think the advantage of this project is that behind all this is the CONAVIO, that they are really, they have a lot of experience doing that. So